So before I so there are a few topics which was left. So one of the topic was this chi-square test. Okay. So where we are now. So we have done this portion. Unit 1 is already completed. This one. And there are a few topics. For example, F-test and chi-square. And this one is done. Okay. So how to model this regression and plotting different graphs. So obviously the Power BI, at least you will have an idea that how to plot, right? Because Power BI is something that is very important. Okay. So before I show you anything, let me do somewhere. Okay. So Skill India Digital. Okay. So just let me open this Skill India Digital Hub. Okay. So this is one of the government portal, and I'm just giving you an idea that how typically this your visualization typically it works. Okay. So this is one of the website of Skill India Digital, and it comes under this skill development and entrepreneurship, Ministry of Skill Development and Entrepreneurship. And if you go and navigate this one dashboard, okay, so there are a few options for the dashboard. Just see apprenticeship, NAPS, DBT, summary, premium analytics, state level attendance, summary, DBT or something, right? So let me just okay, click this one. Okay, if I'm clicking it, just see the this header, the powerbi.com. So what they have done is they had data set and everything, and they have created a nice dashboard. Okay, just see using the Power BI, right? So how Power BI as a data visualization tool is powerful, right? So basically when you take a decisions, because at enterprise level, at government level, when you take some decisions and when you try to create some kind of a policy on top of it, so obviously you must have something in front of you to take decisions. So I mean the data visualizations, how it is important, just see there the implementation. So how powerful Power BI is when it comes to create beautiful visualizations. Just see, right? Because visualization is something that gives you each and every details, even the minute details in front of you, right? Because when you create some kind of a modeling, it's just the output. You don't know, people will not ask you that which model you have employed it to come up with the output. But when it comes to the sophisticated Power BI or maybe any visualization tools, it gives you a kind of a intelligence that is somehow sometime Power BI is called a business intelligence tool also, right? Because it gives you insights based on the historical data. So let me navigate this, and if I go down, it's an overview. So how many people were engaged and they have taken this you can say the service, and how many people have completed this one. Let's say it's 18 lakh, and then how their program is going on. So these are some details what government wants to understand, because when you see any newspaper, what typically happens that you see only the numbers, the KPIs are displayed that 2 lakhs of people get trained in this maybe this session, right? The numbers are very much important, right? So this visualization tools are helping them, the government or maybe other agencies, other stakeholders to take decisions. For example, how many 395 crores are paid. For example, if you take any skill courses, once you complete, you would be given some amount. Let's say 5,000 once you complete some kind of a course, some ITI course. If you have some certificates, you have done it, you might be getting 5,000 possible, right? So these are the some schemes. On the basis of that, the government has paid how much? 395 crores. So these are the some, the data that is displayed on a screen using this Power BI, right? So even if as a, because you people are from management background, right? So I assume that when you become, the business analyst or data analyst for that matter, you have to, for example, if you become someday, the Power BI developer. So at that time, these kind of, the visuals, this kind of a dashboard will help you also. Okay. So my aim is to, to walk you through that how different visualizations can help to take decisions, and it is, in the market and people are taking decisions, right? So it's very much powerful tool. So if you see, there are some, in the Power BI, if you see, there are some, this map you can display. And for example, if I'm just clicking this Bikaner, how many people are, taking this course is 2503. You can easily see, right? Let's say if I go down somewhere in this northeastern state. So these are the few states where, you can see there are few people. But when it comes to this Pune, just see how many people. 3,93,000 people are, in the Pune, they are engaged with this course. They are taking this course, right? And this is also one of the charts, and it gives you a trend. Yesterday, sir has shown you this trend. So these are the few trends that, this financial year 18 and 19, it was the initial stage, and there were people who just, there are a few people who have taken these courses. And there are also, if you see this one, how many people are getting trained, how many people have registered, and the people who have dropped out. There are people who have taken this course, and in the midway, just they left the course, right? So these are the some, the subtle information. So minute details, and that plays an important role. If you see now in financial year, 19 and 20, drops outs are, it's 8,000 people are dropping out. If you go up to this, just see the dropout. So as the time increasing, the drops, the number of dropout is also increasing. But why? Now it comes to why, right? So for example, if you have been employed as a business analyst, and you are doing some kind of a diagnostic analysis, right, on top of it. So now obviously not a single government would want that there should be a mini drop out, right? They will want to minimize it. So obviously they will come up with some kind of program that people do not drop out. So don't you think that if there are some element of, let's say, some kind of appreciations, maybe in terms of monetary, or maybe if a government is saying if you are able to do this course, 100% chances that you will get some kind of a job. So this can eliminate the dropout. The number of dropout might decrease significantly, right? So this is not a way of just plotting the data. The important is that how you take decisions and how you come up with some kind of innovative solutions. So that is the something which is very important. And top of it, as a a management professional, this kind of a tool, a business intelligence tool, plays an important role. And there are many more factors to it. Also, there is something called a time series. So in what time people are, there are more dropouts. Maybe this financial year, if you see there is shoot out, there are more dropout, but you have to find out the reason why people are not taking this course and they are going midway. The possibility is that maybe the market trend has changed. Many people wants to go into data science, data analyst. They do not want to go in ITI, let's say, or maybe some kind of a blue collar or maybe white collar job, right? So I mean, everyone wants to be on a higher scale, and that they want to get paid more based on the skill set, right? So maybe these are the way and the reason for dropout, or maybe possibly where they are getting trained, the area might possibly, maybe the trainer is not good, maybe the syllabus is not well, and also once they are doing this, the feedback, that is also important, that people are not getting good feedback, right? and also their employability is very less. So that could be the possible reason for the dropouts. So you have to come up with this kind of the analysis on top of it. Okay, so if I go down, there are also some charts. You see the social category, right? There are different social categories. So maybe general is more people are general, and if you see the OBC, their representations in these courses, right? SC, ST, the few, right? So, and also if you go by the gender, how many people are, male and female, because government also initiates some kind of a program. If let's say, if you are a female and if you are doing this ITI course, maybe you get some kind of a 10,000, 15,000 for this, right? So they also try to empower women at the same time the people who are deprived, right? So these are the schemes which are working, and my aim is to just to show them that how you can leverage this Power BI and come up with some kind of a beautiful dashboard, right? So these are one of the finest dashboard, and you can also see here at the end they have used this natural language processing. There is something called sentiment analysis or thematic analysis, right? So what they have done, they have come up with some kind of analysis that the automotive sectors, it's a high, it's a bold, right? ITS people are taking more number of the people who are enrolled more in ITS, maybe the automobile sector higher, then electronics, right? Production and manufacturing, right? Agriculture, the less people are taking up the courses, right? Gems and jewelries, right? These are the some courses, right? So I mean, you'll have something in place, I mean everything at one place, and now on top of it you just like to see that okay, so automotive, ITS, and maybe electronics, productions and retail, these are the some electrical, these are the some sectors where people are likely to take, and they are taking more number of registration is there, right? So and also I mean if you are, let's say, a decision maker, so you'll see that which all sectors are not performing, I mean maybe outdated. So at that time also government think of just to enhance the syllabus maybe, and try to increase the employability and try to come up with some kind of a jobs, right? So they will have everything at one place and taking decisions at this scale, right? So if I go down, so you'll have more, you see the electricians, there are more people who are doing this course and becoming electrician, then fitter, then assembly operators. Go down, if you see the retail training associate version, so these are the some courses, and they are taking these kind of jobs, and the male is more than the female, right? So female, the percentage of female is less in ITI, if you see this one. Okay, so these are the some courses. So you see, so you can create a better Power BI driven this a dashboard, and this will look like this, and this is live, right? So and if you become a Power BI developer, and there are many openings for this Power BI developer as well, right? So also you in drop down you can select, let's say, Assam, and you can select districts, gender, special districts, contract type or something. So you'll have everything at this place. And if I click the analytics part, just see what it comes. Let's say if it is coming or not. So analytics is one of the at one place. So let's say just government wants to see, I mean what kind of analysis, I mean whether, let's say, I can also branch it out. I mean you can play with this kind of, let's say, maybe the male, female, general, I mean the financial year, Maharashtra, Pune, and this, all are the districts. You can change the districts. Okay, let's say I want in UP, how many people are there in UP? Okay, so then it will change. Again, it will change. Once you click, it will change. Okay, so this is how you can play with, and it's very interesting to see that how you can create some beautiful this dashboard on top of it, and if you have a historical data. Okay, so this is how it works. Okay, so I mean, So this one thing that I wanted to show you. And at the same time, so there are a few topics which are left. So let me go with this actors in chi-square. So just see the app state and chi-square. Okay. So the chi-square test and F test. So it's a part of this your hypothesis testing. So obviously, it is in the industry you typically get different kind of data. Maybe sometime you get numerical data, categorical data, maybe some kind of discrete informations. Sometime you get this data which are textual format. So unsupervised data, supervised data, maybe historical data, maybe data is coming from some of the telemetry. So there are the different sources of a data, but the task is, let's say you have to do some kind of hypothesis testing, right? So how are you going to do that? So obviously based on those data, I mean the T test, Z test, we have done that. I mean, if your data set is less, maybe less observations. So I mean, the first choice is to go with the T test. And if you have, let's say, a more data samples, maybe more than 50, 100,000 or something, so you come up with solutions for the chat test, right? So I mean, it depends on the number of observations, but when all your observations is categorical, right, then it creates a problem, right? So how are you going to solve that how you come up with some kind of hypothesis testing, how you going to formulate that? So then comes this chi-square and then app test. Okay, so app test, it also you can see when you might have created this logistic regression or maybe some kind of a classifier. So at that time also you come up with you'll see in the output that app test, their values are given, right? So I mean you'll see that what these tests actually tells you, right? But when it comes to this chi-square test, so why we typically do this chi-square test? Okay, so let's say, I mean, you have only the categorical variable. Just see this data here first. So we have a man, woman, right, and dog and cat. Both are categorical. Dog, cat, and bird, and men and woman. Okay. So I mean, this is called contingency table, right? It's rows and columns. It's more of a tabular form, right? So I mean, both data, you see dog, cat, and bird is categorical. Men and women is categorical, right? And now you have some data on top of it. Okay. So I mean, chi-square is statistical hypothesis, is a test for independence between categorical variable, right? So if you want to check whether there is some kind of independence or not in those categorical variable, so in that case you come up with this chi-square. But just remember that both independent and dependent variable in chi-square test is categorical. Both are categorical. That is something that is the you can say the clue when to apply this chi-square, right? So when you have a data set and if you have a variables, both variables are categorical. So obviously that gives you a clue that you have to apply this chi-square test. Okay, so I mean, we will perform this test using this approach, and let's see. So here the data set, let's just read it out. So I mean, we have you have to find out the relationship between these two variables. One is this, let's say, the animal, and other one is, let's say, the human, right? The men and women, they are categorized, right? So here we take a table that shows the number of men and women buying different types of pets. Okay, let's say there are a men and there are they are buying 207 types of dog. Okay, and the women who are buying dogs are 234 number of the dogs. When it comes to words, 241 birds the men are buying. So this is how you can interpret it, but it's in a tabular form. So the number of men and women buying different kinds of pets, their data is given, and whether just we want to conclude that the I mean, the gender and choice of pet are related to each other or not. So two variable, one is gender and other one is a pet, right? So then the pet is into three different categories. One is dog, cat, and bird. But when it comes to gender, we have the men and woman, right? So I mean, whether the two variables, gender and choice of pet, are related to each other or not. So how are you going to verify that whether there is some significance or not, there is an impact of this gender on the buying pattern of pet or not, right? So this is how we want to achieve it, right? And here the problem is that the both variables are categorical, so you cannot apply this guarantee test. So in that scenario, you have to come with this chi-square test. Okay, so let's say there are a total number of you can say the men and women is there, and the cat, bird, and these all data is there, right? Now you want to see their relation with this gender and the pet is there or not. So for that, I have just created this. This is a Python programming, and I mean, you can also, I'll share you this code. It's just a small piece of code. So SciPy is one of the library that you have to install it, because something you have to do some kind of a modeling here, right? So how you store the data here, and also our data is you can say the tabular form, that is called contingency table, right? So contingency is something that is stored in the form of a tabular data, right? So as we are applying this chi-square, so it is there in this package stats library. Okay, so we have a data, let's 207, 282 and 241, right? 234, 242 and 232, right? So here if you see the way we are storing the data, right? You are storing 207, 282, 241 the data. Okay, so we are storing the data, and as this is three, I mean the pet, there are three pet, and this is a male and female. So you have to store data like this. Okay, and there are a few parameters that we need for chi-square test. One is a stat, P, DOF, degree, that is a degree of freedom, and expected value. Okay, these are the three variables that chi-square will take. Okay, and we are passing the data, the entire data, this data. Okay, so how you gonna interpret it? So when it comes to hypothesis testing, I mean, it's always revolve around the p-value. Whenever you come across any hypothesis testing, you will definitely find out something called a p-value, right? That is a more of a probability value, right? So how are you going to interpret it? Let's say we are seeing the significance value 0.05. Okay, so that should be above that value will work, right? So print p-value is, if it is coming less than the p-value, print dependent, reject h0, and if it is coming more than that, then holds true, right? So we have to formulate this. This is a hypothesis testing formulations. Okay, this is nothing but in Python how you formulate this hypothesis testing. So if you run this, so you'll get p-value 0.03. Okay, so h0 holds true, right? So the p-value, I mean, as I already told you that when to reject. Okay, if p-value is less than 0.05, then your null hypothesis that you have to accept, right? So I mean, how you will formulate, this is how you can formulate, because data is like this. Maybe if there are a fourth variable or fifth variable, that can also you can increase, but the main aim is that how you typically model it in Python, right? So this is how you typically model it. So h0, how you gonna formulate the h0, the hypothesis that whether this the null hypothesis. So obviously, as I already told you in the previous class, that for this h0, your hypothesis must be like there is a no, there is a no effect of, right, gender on this the buying behavior of pet, right? This is how H naught work, right? And a reject H naught means the alternate would be that there is a effect, right? So this is how we typically come up with this H naught and H1. So H naught is typically it's there is a no intervention of anything. It's like a ideal situations. But when it comes to alternate, obviously it's a reverse of H naught, right? So when you try to formulate any hypothesis, so in place of null hypothesis, we assume a scenario, idealistic scenario. We do not see any kind of intervention. So there is a no effect of this, and when it comes to the buying, the pet, right? So here, as the value is less than 0.05, it means our H naught holds true, right? So it means there is no effect of gender on buying of number of pets. Otherwise, there would have been some kind of effect, right? There is some kind of you can say association, correlation, that men are buying more dogs, or maybe female are buying more birds, possibly. But here it's showing that no, there is no effect of gender on buying pattern. So there is no association, correlation on anything, right? So this is how you can interpret, right? Now when it comes to F test, so F test also works a similar fashion, you can say, like the a chi-square typically works, but it's just a more of you can say improved version. And so the, let's say if there are two maybe populations, so where if you see the F test, so it's employed to check the quality of variance between two populations. So let's say two populations are maybe coming from a different region, right? For example, if I am checking population from India, let's say one of the state Delhi, and the US, let's say one of the state of US, and because they are coming from two different populations, so one of the state of US and the Indian state Delhi, right? So if we are sampling, so two samples coming from different populations, so at that time we come up with this test called F test. Had it been, for example, if it is coming from the same population, for example within India, and let's say if it is coming from, let's say, the two different states but in the same country, so it is coming from the same population only, right? Maybe their variation, there will be a variability, but coming from the same population, right? So well, is F test is nothing but it's a more of a variation, the ratio, that how there is a variability, right? For example, the pattern, the voting pattern of Delhi and the voting pattern of one of the US state, that there would be significant difference, and possibly there might be no difference. So how you gonna come up with the variability of the voting pattern of these two states can be measured through this F test, okay? So F test is compared to the F critical value. So there are some maths involved in it, but the crux is that when your two populations, when the data, the samples coming from two different populations, at that time you have to apply this F test, okay? So these are the some formula. So obviously we'll capture the variability, the variance of two populations, okay? So it's like sigma 1 square divided by sigma 2 square. So F test also plays an important role, because last time I had shown you this regression. So obviously how much variability and in the dependent variable is being explained by the independent variable. For example, the lottery case, the previous class I have shown you that the buying of lottery, if someone is buying a lottery, is depending on the wealth of a person, right? So if person is wealthy, the high chances of buying a lottery, right? So the how your dependent variable is being explained by, the how the variability in the dependent variable is being explained by the independent variable. These are the some variability. So where also there comes a factor of this F test in that modeling also, okay? So how you gonna through the Python, how you're gonna formulate this. I mean, when it comes to model, if you have a data set, then how you gonna model it, right? So let's say you have some group, let's say group 1 and group 2, okay? Both are categorical and you are creating a data, okay? So I mean, for that, maybe let's say there are two groups, and maybe let's say you can say these are the some, you can say the percentage of passing, let's say percentage of passing. Let's say this is group 1 is US and group 2 is India, right? And these are the some students, and they're let's say out of these, you can say 3 scale or 5 scale, they are getting this, the score, and they are coming from two different population, obviously, okay? So how we gonna formulate this hypothesis testing, because F test is very much important, right? So these are the some, you can run it like this, and because you have to convert this array, because converting the list into array, because this is some list, and you have to convert it into array, okay? And then you have to calculate the variance. The variance formula is this one, np is I mean, here you have this numpy, and the variability is var group 1. So what is the variability of variation of group 1? We are capturing using var, and then we are printing it using np. So np.var group 2. So these will calculate the variance of each group, that group 1 and group 2, capturing using the var functions and storing whatever data is there. So we are passing it and storing it in np, right? Multiplying it with np. So it will give absolute value here, and this is the formula of f test. So in f test function, this is f test function, and whatever variability we had captured here, passing this group 1 and group 2, group 1 and group 2 here. So we have in group 1 0.28 this one, and in group 2 this one, and this is the entire formula of this f test. So what is the formula of f test? So f test is variation 1 square by variability of this group 2 chi square, right? So this is how we typically calculate. So once we formulate this, okay, this is just a formula, okay? So once you run this function and passing this x and y at the end, so x and y, when you are passing it, so once you are passing the entire group 1 and group 2, it gives you this a value, right? And whether it is the value is less than 0.05, okay? So whether there is some effect of group 1 and group 2 and coming from two different population or not, that can be judged through this f test. So value is, if you see, the value is less than 0.05 here. So I mean, how typically you compare, and when it comes to judge this f test and t test, okay? So I mean, for f test, as I already told you, that when it comes to check whether the the data coming from two populations, or maybe the variance is there or not, and how much variance is there if sample is coming from two populations. And two population is obviously, I mean, as I already given you the example of one coming from India, another coming from US, right? So two different populations, so, and both are categorical variable. At that time you just come up with this f test. But variance from one population or process to be a specific variance, but if it is coming from one populations, okay, and within one population, then you have to come up with this chi square, right? And it is similar to two sample t test, f test, and it is similar to one sample t test, okay? And also the data restrictions, when it comes to data restrictions, so whether it forms, if you have a sample data, whether it is forming a normal distribution or not. But when it comes to f test, we have some kind of normal distribution, but it's a roughly normal distribution. It doesn't form a well-shaped curve, right? Because when you see, when you typically say that your data follows normal distribution, so there are I mean, once you plot it will follow a normal distribution, says like it has some kind of a bell-shaped curve, right? There are some bulbs, right? But in chi-square, you are not sure of any kind of a distributions. Okay, so how you distinguish from f and chi-square? I mean, this is just a small, a tabular representation, because the both there will be some categorical value. Okay, so this is how your chi-square typically works. So and you can also run, because there is no data set, and you can modulate it using the sample data points, and you can run it, because it's just a small case, and you can see that how chi-square and f-test typically works. Okay, so now let me just show you another this now we people are here, so z test, t test, f and chi-square is done. So these are some stats that how we typically perform when it comes to hypothesis testing, right? So I mean, hypothesis testing is base, I mean, when you have any business problem, we typically formulate some kind of hypothesis testing, formulate some kind of hypothesis test, and then we start gathering data, and then we perform some kind of a modeling, or maybe I mean, the decisions then come after, when we formulate this kind of hypothesis. Okay, and in unit 2 we have done this, all the this libraries and all, and I have shown how a Power BI can be one of the a tool to create nice visualizations and take decisions. So now when it comes to this this unit 3, so we have some kind of a modeling, I mean, the you can say the time series analysis. So how you perform this time series analysis. Okay, so just give me just some seconds. So just give me a second. Okay. So when it comes to this time series analysis, so we have something, in time series. Just confirm if my screen is visible just once. Okay. Hope it is visible, right?
Yes, sir, it is visible.
Okay. So when it comes to this modeling, right? So I mean, time series, we have seen it, that how this time series works. So just avoid the time. It's 1 3. So time series, I mean, how we model it if we have a data, and so there are different algorithms, as we have discussed few earlier. Like for example, there is something called moving average and exponential models, right? So I mean that if you have a data, if there is something which are which are moving exponentially, which are increasing exponentially over time, right? So at that time, how you gonna model it, right? Because time is one of the factor that is your in x-axis. So when you see any time series data, you will have one of the component of time in x-axis, and y, whatever there, whatever data you are collecting on a y-axis, maybe the sales, maybe the number of cars sold, maybe other factors on a y-axis, but there is a one factors which will always in the x-axis, that is the time. So the dimension of time will stay there in a time series analysis. Okay, so I mean, there are different filtering techniques typically we say. For example, when it comes to time series analysis, so maybe you can use this moving average. I mean, the average, for example, the sales of a car, right? So let's say maybe 20 years back, 15 years back, At that time, there was no much exposure of few tools, time series tools, you can say. So maybe the company used to forecast it. So I mean, whether how many number of the number of units they're gonna sell it, right? So obviously, when it comes to manufacturing uh, anything, you typically forecast it because you don't know what will be the demand and supply, right? Just to match the the demand, you must have to think on the supply side also, right? Just to create a supply chain, better supply chain, you have to come up with some kind of analysis, that the time series analysis. So I mean, the moving average was one of the the traditional method at that time. So I mean, the number of cars, let's say the January, February, March, they want to forecast it. So obviously they had some kind of historical data. So they used to average it out in every 3 months. And based on those average, they used to calculate that, okay, in these 3 months, let's say there are 100 car that was being sold previously. So obviously might possible that maybe 105 numbers of cars might be the possible forecasted for, let's say in next 3 months possibly. So this was the one of the the traditional method at that time for the moving average. But because the moving average is more of there is a no science, you can say there is a no mathematical, you can say the funda was involved. It was more of a gut feeling, right? Okay, so the company that there, people used to forecast, based on their analysis. So and the maths, the kind of modeling that required, the kind of intelligence to the model required was not involved in that. So then the people come up with a different time series analysis. So time series also has some kind of, you can say, the deep learning models. As we have some traditional models, we do have some kind of a, the deep learning models. So let's say you just want to understand, the predictions, maybe the, you can say, you have some kind of algo trading. That is something called algorithmic trading, right? So they're also involved this time series analysis. So in trading, typically you'll see people do use this seasonality component, and they forecast it, right? So there are different models. So now you'll see that, okay, so this is one of the meme, you can say, and the meme says, and uh, I mean, it's finally found it. I finally found it after 15 years, right? So this is one of the meme you can relate with. How people predict this stock price, because it moves. Sometimes it's very difficult to predict when it comes to a stock, right? When you invest money in a stock, so it's very difficult for people to the whether it will. I mean, how it typically behaves. Sometimes it goes up, down, and maybe the. I mean, if you are not from that background, or even if you are very good in stock market and all, still you get confused that when to invest in and when to withdraw money, right? So and when to keep it, right? So these are the some problem that people struggled, because they had a data and everything, but they do not had the sophisticated the intelligence based modeling techniques. So at that time, the people come up with this time series, this analysis. So now, how if you see this visual, so there are different techniques. So it was the exponential smoothing was one of the techniques which we are discussing. So the what typically it does. So when it comes to when you say smoothing, right, of a time series data, what we typically say, okay. So if you see on the right side, let's say June, July, and August. If you see, let's say this is the stock price movement, right? So it is going up and then going down in August and something, right? So the smoothing, what typically it does. So it removes certain frequency, and for example, we want to remove noise to emphasize the signal in the time series before you begin our analysis. So what it typically does. So removing noise improves our data quality. So noise is a more of you can say the outliers, maybe some kind of irregularity in your data set, right? So for example, you have let's say 10 years of a data of let's say some kind of a financial projections, right? And now you want to model it, right? So you want to create a model on top of it, but there are some irregularity, right? So obviously when your model has some kind of irregularity, noise, maybe noise could be the outliers. So obviously when you have outliers in your model, so obviously your model will not generalize it, because the generalization is more of a, I mean, the understanding pattern in the data, right? So your model will too generalize it, so it's gonna overfit it. So the problem of noise is also because it inflates or it's embed this you can say a kind of overfitting, right? So just to avoid that, you have to remove this kind of a noise. So as a, if you become a data analyst or maybe a data scientist, at that time the data preparation, data ingestion, data preparation, cleaning, come up with the feature selections, so and the feature engineering, these are the some I mean the typical part we typically do. And 50% of the time people do struggle with this kind of data pre-processing part, because once your data is pre-processed, once you are removed, this error, maybe the noise, maybe the irregularity, you are good to go and to model it, right? So I mean, so just to keep track of it in the time series analysis, noise is something which we have to take care, right? So data smoothing is basically the averaging data points with their neighbors in the same time series. And it says data smoothing is similar to filtering, in which high frequency are suppressed to extract the low frequency signals. Okay. So, I mean, you might have heard of, something called a trimming, right? So, for example, in a garden, if you have different trees and you want every tree to be look similar, right? So you just trim it out, just smooth, right? So that, you can stack the, even the low hanging, you can say trees, and you can suppress the higher trees, right? So that it looks similar, right? So the main aim is to make your data similar, it sounds similar, and you remove some of the higher frequency, because if there are some higher frequency in your data, it's gonna suppress it. For example, in a house, let's say in a crowd, and there are a small kid and who just want to speak, but there are a lot of noise, so their voice will be suppressed. So obviously you would want that there should be some a low pitch voice, even if they are adults, so that the kid's voice could be heard, right? So this is this is smoothing, right? So data smoothing is very much important, right? So now there are different techniques. For example, if you see, I mean, the different approach is to how you smooth our time series, right? So I mean there are the moving average, kernel is smoothing is something, exponential smoothing, and depending on the amount of noise in the data present, you're gonna pick up whether we want to pick up this moving average. Kernel is smoothing is some of the one of the finest approach, because when you apply the kernel, the ability of this algorithm is to come up with this hidden pattern also, right? So the kernel approach also, when it comes to support vector machine, you might have heard of in the classifier algorithm, or maybe possibly I'm just assuming it in other classes. So support vector machine is one of the also technique where this kernel approach typically employed, right? So how you gonna pick up these time series models? Because once you have a let's say a business case, now based on this, how you gonna pick up the which model to use? Because your intelligence is being tested, that how you gonna come up with this algorithms, because we have a different algorithms now, and the market is flooded with different machine learning time series algorithms now. We have a different sophisticated algorithms now. you have a different this foundation model, chat gpt, deepseek, quen. There are many more. Even I don't understand that how these models are coming, right? So every day you come up with different models, so they can also perform this kind of a task. But the point is that when it comes to these organizations, so there you cannot apply all the foundation models to come up with the modeling part. Ultimately you have to create your own models based on the custom data set, right? So how you, typically you will use it. That is the intelligence, that is the human intelligence that is required. For that you must understand, right, that the basic science behind each and every algorithms, that how it typically works, right? So when it comes to moving average, right, so how typically this moving average works. So if you see this, I mean, the visuals, the data, if you see, if I'm applying this original approach, smoothing and kernel approach, there are three, right? So it's, we have a smoother this and the kernel approach. So this is how our model is typically working, right? So if you see this, if you read it out, right? So I'm just giving you an idea and then I'll show you through Python. Okay. So moving average is one of the approach. That use some kind of a sliding window of fixed length. All the data points are averaged with the same weight. So it's like a wiper, right? You might have seen a wiper, that how you wipe it out the water, right, in your kitchen, right? So it has some fixed length. So you try to move it on the right side and maybe on the left side, depending on the carpet side. The same way the moving average. So we have some kind of a filter in a particular dimension. So we have some sliding window of a fixed length, right? So this is how we the moving average works. Okay, the approach is well suited for data with little noise. Okay, for example, if you are capturing a data of, let's say, sales and the revenue of, let's say you are a startup and you have started your company 5 years back, and now you have a data of sales, let's say, and let's say you are a manufacturing company, and now you have a data of 5 years now of each and every month, right? So obviously the data which you have captured will have a little noise, not too much, because the data is very small, and that there are high chances of being the small noise, maybe the little noise, right? So at that time you can come up with the moving average. But when your data has different the features, let's say you have 10-15 features and you have, let's say, 20 years of data over the time, right? So there would be higher chance of the noise in it. So at that time you cannot apply this moving average, because in this approach, if your data points has a little noise, so noise is more of a kind of missing the lead, you can say, outlier, some kind of irregularity. So at that time, you cannot come up with this moving average, cannot apply, right? So the moving average cannot capture seasonality and thus should not be used for time series. The biggest you can say the drawback of moving average, as I already told you, that the moving average was typically with the traditional, if your data set is small, and it typically more of not more scientific, you can say there is no intelligence involved in it, but it's just the initial, you can say, the traditional ML approach, time series approach. To at least there was earlier, there was nothing in a prediction, so now you have something to predict, but there is no much intelligence involved in it, right? Because also it is not capturing the seasonality, because when it comes to time series, seasonality is something which is very much important. If your model is able to crack the seasonality, your job is done, because the time series obviously it fluctuate over time, so seasonality comes into play, right? But moving average doesn't capture it. So the approach cannot calculate the value at the start and end of the time series, depending on whether one-sided or two-sided moving average. For example, if you have to capture it, so if you want to forecast it, the problem of this moving average is that For the moving average, at least you'll have some kind of 3-4 months of a data, at least 6 months of a data, because in moving average maybe you calculate after three months of a data, you just sum it up and then you forecast it for fourth month, right? So you must have some kind of a data, historical data, because they are not able to forecast it for the starting, because for the starting month in the January, let's say if I want to forecast it and I just want to apply moving average, I won't be able to, because at least I must have a fourth month of a data at least to forecast it. Okay, so sliding window is put around a data points and the values within the window are averaged before the window is slide to the next data points. This is repeated until the time series. So the previously, if you remember that, in the sliding window, let's say I'm taking a sliding window of 3 months, right? And once I have, let's say 12 months of a data, so first 3 months I would just average it out, and the fourth month prediction would be this, the average of these all the 3 months. Okay, so the sliding window of, let's say 3 months, maybe I take fourth month, fifth, sixth month. So I can increase my sliding window, and so that I can capture the more variability in the time series, right? So I mean, it depends on the data set and the kind of a data. So if you have a data which is kind of a bell-shaped curve, which are more of a, the informally distributed. So in an ideal case, your data would not be, this normally distributed, because you will not typically get this normally distributed data in ideal case, right? So obviously once you remove the noise and some kind of irregularity, and then you come up with this assumptions of that your data is normally distributed, right? So this is how typically your moving average works. And for the same thing, you'll see these are some maths. I mean, maths, I'm just showing you that how you can calculate the average of these, the moving average. So I was giving the example of this the 12 months of sales, that you have started this startup, right? And you are manufacturing something and you are selling. So I mean, the for all the 12 months, you, let's say your data in Excel. So first 3 months you will average, let's say in first month you sold 10 units, then 12, and then 15 units. So 10 plus 12 plus 15 divided by 3. So whatever comes would be the forecast for fourth months. The similarly, you can slide to the next month and you can club 3 months and average it out. So this is how it typically works in the moving average. Just you try to move the average of the 3 months. It's like a sliding window. Also, you can increase the month. Let's say you can take 4 months sliding window, fifth month sliding window, all 5 months, and all 6 months sliding window, and you can forecast it, because once you increase the this sliding window, the length of the month, the higher probability that you might get closer to the predictions. Okay, and possibly it doesn't happen all the time, but when you increase the window, possibly there might possible that your prediction might increase and the accuracy might increase. Okay, so now there is second concept, the smoothing, right? So the kernel smoothing is similar to moving average, right? So how the kernel smoothing is similar to moving average, but here you see, the window is similar. They have a sliding window which looks quite similar, but you'll see on top of it, it is more of a you can the bell-shaped curve, where you see when your data points are normally distributed. Typically it is called a Gaussian distribution. So it is assumed that your data follows Gaussian distribution. So it's more of a bell-shaped curve. So the kernel smoothing is similar to this moving average, and the only difference is that the weights for averaging in the sliding window. So earlier we do not had weights in the sliding window, but when it comes to kernel, we'll have some kind of weights, right? So just assume it when I say weights. So for example, in linear regression and the previous class, so where there had some weights, for each and every input features. So when you model it out through this training data set, we had some kind of a weights attached to each and every features. Let's say I was at that time, just I'm assuming there was a case of lottery, right? So lottery and the buying of a lottery was depending on wealth, education, maybe you can say wealth, education, and maybe whether and the age, let's say. So when I modeled it, there was a weights for each and every the feature. So that is the weights, okay. And weights, how weights comes, it is coming from the internal data set. I mean that during the training data set. So your model explicitly gives you these weights. You do not assign it, right, forcefully, right? So your model learns from the training data set. That is the weights. But when it comes to hyperparameter, right? So you might have heard of something called a hyperparameter. So it is like, I mean, the how you typically fine tune or you tune your FM radio station. So for example, whenever you get some kind of fluctuation in the voice, you typically try to set it out. For example, 93.5, right? So if it is 93.4 something something, you'll get you'll not get clear voice, right? So at that time you have to fine tune it, you have to hyper tune it, right? So it's like a tuning the model, right? But how you tune it, you just put some external effort, you just set it, right? So that is your, I mean, the hyper parameter. That is also a kind of a weight. You just give it the model externally. That is your hyper parameter, okay? So the weights depend on the shape of the kernel function. So let's say if the shape increases to this, their weights gonna increase, right? Due to the similarity of moving average, the advantage and disadvantage are also similar. As your models follows this moving average, but on top of it, it works on the average, it works on the weights. So that is the something you can say the pitfall or maybe the drawback of moving average is being incorporated here, addressed using this kernel smoothing function. At least they have some weights. So it is more of a some kind of a intelligence, some kind of a mathematical formula that you have introduced. That is more of an intelligence based now, right? But earlier in moving average, you do not have anything. It was like a gut feeling and just you are averaging it out, like it's a childish work. But now you have some weights, so you have some specific explanations for the predictions for forecasting now. So that is why kernel smoothing is much better than this moving average. If you want you want your predictions to give much better result, right? But still they have all the advantages kind of it carries with this moving average, right? So now the formula is as it is saying kernel smoothing. So obviously the formula is this. But the point what I was trying to bring into attention is that the kernel smoothing will have a weights plus moving average. That is your this kernel smoothing, right? And earlier in the class I have also shown you that how in the kernel smoothing weights plays an important role. So you just multiply some weights of the input features and then divide by the average. Everything is will follow the same formula here in the moving average. If you see, they have the similar formula, but there will be some weights here. It will be multiplied by the some weights. Okay. So now when it comes to this exponential smoothing. So exponential smoothing is I mean more of a if you see okay, there is some problem with this. So okay, so exponential smoothing, when I show you the exponential smoothing, so obviously it captures the complex you can say the behavior. So now we were at moving average, now we are jumping on to, then we jumped on to kernel smoothing. Now we have something called exponential smoothing. So moving average, kernel smoothing, and exponential smoothing. So as I already told you that when you have a complex now when your data becomes complex, and now complex means when you have higher dimensions data, maybe 10 12 features in it, and that is all are time dependent, you can say, at that time your model will become more complex, right? So at that time, how you gonna capture, right? So because if your data is a linear, for example, when I say a linear data, I mean, I'm telling you that, for example, if I'm moving something, it will move in the same directions. That is your, you can say, in the linear data. But what I tell you that if I increase x, other to increase in random fashion, that is your non-linearity. But the point is that then obviously the human cannot come up with this non-linearity. I mean, they cannot capture it because it's very difficult for us to capture this non-linearity, right? So at that time, these models, exponential smoothing is very good in capturing the non-linearity. That is, I mean, very much important, when it comes to this, this kernel smoothing, they were not able to capture this complex behavior, non-linearity, but exponential smoothing will capture this non-linearity. Okay, so this is how the difference lies with moving average, kernel smoothing, and exponential smoothing, right? Kernel, the exponential smoothing will capture the non-linearity, non-linear pattern in the data, right? So how we typically captures this stock price? Okay, so let's say stock price can be captured also through this, you can model through this moving average also, right? So for example, this is the data set, and I will be sharing you this data set, but let's have a look on it, right? So we have some, let's say 20 data points, and you have a date, let's say 2903 and 2022. So the stock was open at 2638. It was high 260 and low was this. Closing was the close. The stock closes at this point and adjusted closing. So when you see this stock, data, it looks like this. Okay. So I mean, they have this kind of a trend, and they have captured it somewhere. And now you have to model it. For example, that you have to forecast it that if let's say after 6 months at this day only, what will be the the open, high, low, and close, right? So at least this gives us a, I mean, if you have some kind of a forecasting that stock price will go up and you will get more money in your account or something. So at that time, this kind of forecast will work on. So how to manage your different portfolio, different financial, how you just try to put money in different portfolio, and how you want to invest your money, right? So these are the some approach, and this moving average at least can give you better understanding. And also people, those who are very interested in this, they can also model it, and they can create their own program, and they can forecast it for themselves, right? And ultimately, sometimes you have to depend on the news, and a different kind of the state's policy, and the world situations, and based on that, people do invest money in this stock, right? So now I think maybe it's visible because it's a PDF. So I mean, how we typically model it. So for modeling, we have a different data, as the data is saved here. So let me just see if this data is here or not. So okay, okay. So let me. It's PDF, that is why it is creating a problem. Okay. So 1 minute. Okay, just give me a minute, and let me pull out better PPT. So just give me a minute. Okay. Sorry for delay, and just let me show you. So just somewhere. Okay. So we had some data sets. So let me show you. And if it starts showing, just let me know because it's a Python program. Okay.
Yes, sir, it is now visible.
Okay. So just see, and I will be sharing you. So these are some library, and okay, for that you require pandas is required for data manipulation and everything, and for mathematical calculation you always require this this numpy. And as as your data requires to be to be some there are some visualizations also. So time series visualization, so matplotlib will help you. And we are seeing just to create a default style and create in program itself only in line. Okay, so these are the some libraries that you typically require. You have to import it as our data is somewhere saved here. Okay, and reliance data. Okay, there are stocks, I'm calling it. So it is there, and reliance this is you can say user defined, and we are reading, right? Our data is stored here. Okay, so we can also run it. And for example, we have some Jupyter notebook. Let's say we have a Jupyter notebook. So you can open it, and hopefully you people have a Jupyter notebook, or maybe you can use this VS Code. Okay, so maybe you can use this VS Code also. So the beauty of VS Code is that it gives you integrated environment, and you can use it. So okay, so this let's say uh, if you have some also, let's say this Colab, so you can also use Colab. Okay, so data is here, and is there any way to I don't know if there is a way to project it. There is no. Is there any way to just present it? There is no, right? Okay, just leave it. So our data is here. Okay, so what we are seeing that the index column will start with this date. Okay, this date, and parse date is true, and data is in CSV format. And if you are seeing head, it will print the first five column, first five rows, right? So let me go down. These are just output. Once you run this command, so this will give you this all these things. Okay, so don't worry. So they will have some data here. Okay, something like that. Okay, and now we have to see the close dot frame. All are, for example, high, open, high, close. All these things will get displayed here. Okay, so I will be just showing you, but it is not coming in the format. Okay, so let me do one thing. Just let me just give me just a minute to just a minute. Just open. Let me open it in a format. Then it will work. So open it in a format. So let's say if I'm opening it in a format, maybe okay. So if it's open in PDF, then it will work much better. Okay, so let me give it a try. Okay, so just see. Now just see this one. Okay. Hope it is saying. Okay. So now let me start. Now it will show you. Okay. And present. Okay. Now it will show. Our data is stored somewhere in CSV. Now it is visible. Okay. And you know the libraries to be imported. Okay. If you go down, there is just this. Once you run it, so you'll see some kind of a code as we have written the command called redance.head file. So it is showing the first, this 5 1 2 3 4 5. These are the first 5 rows they are giving us. Okay, and we are seeing we are just saying in this command in 3 that reliance equal to reliance 3 close whatever in the close. Okay, is to frame. Okay, so whatever is in the close, what was the closing price, you can see it is being displayed. Okay, and in this, if you see in this code only, we are saying exponential smoothing. Okay, this is one command, and close rolling 30 and mean. Okay, so for the 30 we are taking exponential smoothing moving average. Okay, for the first 30 you can say points, and we are creating a mean out of it. Okay, so it will create a mean here. Okay, for this point and close and this point, and this will store it something like that. Okay, so exponential smoothing. Okay, and here using a window size of 30. As I already told you, you can also decrease the window size. Let's say in moving average, let's say we are taking a window size of 5 10 15. But if your data size, maybe if you have a more data points, at that time you can also slide, because it's a sliding window. So here I'm just sliding my window size to be 30, right? You can also take 20 15 and just see how their prediction accuracy is on the test data, whether it is going high or low, right? It's a point of a research, that how much should be the sliding window if our data size, let's say 1 lakh, what could be the sliding window size, right? So sliding window we have taken, and now the close, the sliding, this moving average 30 with the sliding window, and we just want to plot that how it typically looks like with this sliding window. If you see this, the sliding window, something like this, your plot will look like this. Okay, and if you see this, I'm just taking a random points here. Your real close was this, but your model is predicting like this. Okay, if you see, there are points which are very closer. Just see in this, they are very closer. Your exponential is moving average is very much close to the this original one, right? But here there is a much difference. Here just see there is a higher difference, right? But if you see in a broad level, somehow it is closer to your the original value. The predictions is closer, right? So here comes the point of selection of this sliding window, because if you are able to crack this the sliding window, that whether I should keep a sliding window, the size of sliding window to be 20 25 30 35 40, you have to see it's like a iteration process. In first iteration, if you are capturing, let's say, variability of this, maybe the variability is less or higher, or maybe the accuracy part or the prediction part, right? So at that time your model will give you a much better accurate result. But it's like randomly you are selecting here the window size to be 30 here. Now we are plotting the using the exponent. Now we have used this moving average. Okay, we are able to see that how if you are using this moving average, this window 30, sliding window 30, how your time series model will look like. So as I already told you, it's going up, but here it is reverse, right? So due to the irregularity, it's not like every single time your model will give you accurate predictions. But if you see all these data points, somehow it is similar, right? Somehow it is capturing this the predictions with the the accurate the previous, even the historical data points, they are matching. Your prediction is matching with the historical data points. Now I will be applying this moving average, right? So moving average, how you gonna apply it, right? So for exponential moving average, so as I already discussed that in moving average, we only have this average of the maybe the 3 months. If you are using moving MA of 3, now here we are using MA of 30. It means 30 months all add up from X1 to X30. We will add maybe the revenue divided by 30. So it will be the projection in 31st month, right? So this is how our this is the moving average in this is explaining, right? But now exponential is smoothing. So what I explained was that there will be some element of weights, right? So weights will eliminate the the disadvantage of moving average. So just so now we have the same algo here because we will plot it out. So we have matplotlib library. So the same data set we are using, this Reliance CSV, right? Data set is here. Now how we are modeling it through this exponential sorry, this kernel one or exponential, right? So this one is exponential, right? So let me see. If it is exponential, yeah, if it is exponential, then you will be using some kind of a this weights plus the irregularity. You will be capturing the complex behavior, right? So let's just see. Okay, so here where is that? Okay, so now as head 5 we are displaying this one, and this, if you see, this exponential is smoothing. Now we are just taking 30 as a sliding window. Okay, so window size is 30, applying moving average only, but exponential is smoothing. So as I already discussed you, when you are employing any kind of exponential is smoothing, it will capture the behavior of moving average plus this kernel smoothing and whatever behavior it had with exponential smoothing. So it is a, you can say, the improved version of moving average, kernel smoothing, and then on top of it it's exponential smoothing, right? So it's a more evolved version of this smoothing average, right? So here we are applying this exponential smoothing, that is why EWMA30 window size, okay, sliding window size, and ultimately it is the mean that will revolve around, because the mean is something when you plot this you can say more of a bell-shaped curve, right? That is why it looks like a bell-shaped curve. So mean, whether your value revolve around mean or not, if it is revolving around mean, it means your distribution is following this bell-shaped curve. That is a Gaussian distribution, normal distributions, right? So it will follow like that. So that is why here the mean value, that is why you are capturing the mean of 30 window size and applying this exponential moving average. So that will capture all the non-linearity component also in your time series data. That is the beauty, right? So once you apply this, this will show you the at what price your stock gonna close, right? And also if you see 2622 and your exponential is smoothing also saying that okay, it will close at 2622. Just see the closeness, right? It is more of a close, right? If you see second projections forecast 2672, here it is 2648. It is more closer, right? Also if you see 2634.75, 2643, right, and 66. So if you see how your predictions is with the time when you imply this exponential smoothing, right? So more closer, right, that stock is gonna close at this point, right? So if you see the evolvement of how you apply, so we have applied moving average, kernel smoothing, and now we are applying this exponential smoothing. So exponential smoothing is more of a capturing the non-linearity behavior. So if your model, just let me give you one clue that if your model is able to capture the non-linear pattern in the data set, that model will have a more value, right? So because everything, you do have some models, many models, traditional model, they capture the linearity, I mean the linear pattern. For example, if I'm increasing the sales, the revenue will increase, right? So that is the linear approach, that if you're increasing something, other will increase in same fashion. So that is a linear approach. But when it comes to the non-linearity, because obviously the intelligence comes into play when you're able to capture this non-linearity, when you're able to crack the non-linear pattern in the data, right? So exponential smoothing is one of the sophisticated algorithms, time series algorithms. They capture the non-linear behavior here, right? So you see the kind of the predictions it is giving, right? It's much closer. If you try to find out the error, right, how much deviation is from the your actual to the predicted value, you'll see not 5 to 10%, even 5 to 10% is much higher, I'm telling you, right? Maybe closer to 5 to 7%. So 5 to 7% error in a predictions can be eliminated or can be taken care of, right? So that is not more. But when it comes to 30-40% much higher, that the actual is, let's say, 20 and your model is giving, let's say, 80, so there is a vast difference, there is a huge error to it. So your model is doesn't lie anywhere. Okay, so when it comes to this this time series, so I will obviously this exponential smoothing is one of the top you can say the algorithms that you can use to eliminate the noise and also to capture the nonlinear behavior, the nonlinear pattern, right? So you see also the few data points and their predictions, their forecast. If you see 2655, 2647, much closer, right? 2663, 2650, much closer, right? So 2247, 2325, okay, it's a bit higher, but 2303, 2317, a kind of a bit higher. But if you average it out, you'll see a kind of predictions, it will lie somewhere. And if you increase the number of data points, exponential smoothing will work much better, right? So I mean this is how we typically interpret it, right? And let's say I tell you to increase the number of the window size. Let's say if you're increasing the window size, so sometime what it happens, sometime if you increase the window size, possibly that your prediction may go in both directions. Possibly it can create more maybe maybe it will fall somewhere in the outlier region, right? So I mean that is the one, you can say, a case where you have to see that what would be the ideal case, that what would be the side of this sliding window, right? So whether I should select sliding window for 10 or maybe 20, 30, 40, 45, how, right? So I mean it depends on the size of your data set. And if your data points are too much non-linear, so at that time exponential smoothing and with the certain window size will work, right? So now here if you see the exponentially smoothing, so how it typically looks, if you see the previous one, just see this one, their window size, if you see the length of this, how close these are, right? These are much closer to the previous one, right? So let me show you that how it is much closer, right, with the moving average. What is the moving average? Okay, this was the moving average, right? Just see the length is much higher, right? But when you apply this exponential smoothing, it has reduced, right? So it has reduced. Okay, see it has reduced. Okay, in exponential smoothing, just see it has reduced significantly, right? So if you experiment and if you increase slightly, if you tweak the window size, might possible that you will just may achieve up to this window size, right? Their difference, right? You're gonna achieve up to this. So this is how you have seen that the which algo is to be more in aligned with non-linear data, right? So now this could be one of the huge case where if I ask you that if this is happening, right, with the moving average and with exponential smoothing, it means your data had some kind of a non-linear pattern, right? This is a clue of coming up with the you can comment on the data set, because we do not have anything in our hand, in the first hand, that we can tell that, okay, by looking at the data set, that it's non-linear. It's very difficult to tell, right? But if our model is giving the difference, is we are able to calculate that once I applied moving average and after exponential smoothing, if there is some less gap and the error part is reduced significantly, it means obviously our data point had non-linearity, right? My model was capturing the non-linear behavior. That is why my actual and the prediction accuracy is somehow minimized, right? So you see this one also, it is much closer in exponential smoothing, but in moving average it has some gap, right? And also it has, they have somehow reduced. So exponentially smoothing is obviously kind of the evolved version of the smoothing average, right? So this is how it works. Okay, so now just I'll take not less than 10 minutes. Okay, so okay, this one chi-square is a lecture 12. Okay, okay, so now we are able to see how it typically works. Okay, so now what we are able to do, we are able to capture this, and let me show you that this your okay, okay, so moving average and this exponential smoothing is everything that is covered. Okay, okay, and one minute. So we have applied all these three algorithms and we have seen the result also. So I will be sharing you this. Okay, so let me just give a small clarification here. So in exponential smoothing, okay, just give me another 2-3 minutes. So moving average was capturing this this only the normal averaging. It's more of an averaging, right? And when it comes to kernel, when you see the word called kernel, just see there is some weights. Okay, it's like a kind of a dimension, increasing a dimensions, a kernel approach, right? Creating extra dimensions, creating something in a higher dimensions is a kernel. Kind of a straight line, you can say, a kind of a plane. That is your kernel. Kernel is nothing but it's an equation of a plane, right? So when you are employing any kernel, it means there will be some weights. Okay, just remember that. But when it comes to something exponential, obviously it means there will have some kind of a non-linearity behavior, something like e to the power minus x, right? So these are the some way to just remember that moving average, kernel, and the non-linearity, that is exponential. So whenever anything, if I'm telling you something going in an exponential way, it means something going in a non-linear fashion, right? Something in a non-linear fashion, that is a exponential, right? So I mean, and this approach, as and also when we have applied this algo in our this data set, we have seen that the out of all these three, exponential smoothing with the window size 30 was working well, right? So this can eliminate the previous the you can say the prediction accuracy, and I mean the as my prediction accuracy was was not aligned with my the actual of the ground truth, but when I applied this exponential smoothing, it is matching with the ground truth, that is my actual predictions, right? So this is how are these models typically works, the time series sessions, and also the time series models, and when you see across the domain, it's not like you can only use it with the more of a you can say the finance domain. You can also apply in different domain, right? So that for example in marketing, maybe in the HR, maybe also in IT, right? Different domain you can apply this time series. Okay, and also there are some algorithms which I pointed out in coming class. I may be using this Araima. So that is just a extension of this moving average, right? So Sharaima. So where we will see the, now we have seen this moving average, this kernel smoothing and this exponential smoothing. Now we'll see in the next class that how this ARIMA model, this also extension of moving average Saraima model, how it typically works, right? And also at the end you will see some of the deep learning time series model, that is also LSTM, Prophet. There are many more which I'll try to explain you that how all are the evolved algorithms. I mean that can work and that you can apply, because ultimate game of this time series is to find out the non-linear pattern, right? If your model is able to get the non-linear pattern included in your training, right? So when you are building a model, your work will be done, right? So this is how your time series model works. Okay, so yeah, so this is all from my side today. So Sakshi, are you there?
Yes, sir.
Yeah, just take attendance, and I will be uploading all this and try running it, because in class it's very difficult to run, but in the coming class I'll show you these Araimas, and all that. Okay,
Okay,
so
sir.
you can run, because data set is separate, so I'll show you the data set and also I'll upload it. Okay, so just take attendance and
Yes, sir. Just a second. Done, sir.